Welcome, everyone. This is Margie Tatro, along with my colleagues Kathy Boys and Matt Jones from GridWorks, and our teammates from EPE and E3 here to facilitate a conversation about the demand-side scenarios that were the subject of many different model requests that came from stakeholders. And so we'd just like to remind you it's May 6th, 2025. We are recording this session, and the link to the recording will be posted on the GridWorks website, along with any slides that get presented today. Those materials will also be loaded on the GridWorks website. So with that, our focus for today is on the approach and the parameters for two demand-side scenarios. And our format for the conversation will be first to hear from EPE and E3 about how they're envisioning the requests for stakeholder input on the commercial and industrial side of demand-side scenarios. We'll have a very short discussion on that, and then we will shift to the conversation about demand-side resources for residential applications and have a discussion about that. Again, the goal for today is to refine those parameters such that the EPE and E3 team can conduct the appropriate modeling along with the scenarios that they've previously described they're going to assess. And with that, I would like to, after all these conversations, we'll have EPE and E3 talk about their next steps. And of course, we'll all look forward to meeting back again on May 21st for our workshop number 5 to continue conversations about modeling results to date. And so with that, let me please turn the podium over to the EPE and E3 team to share their slides and talk about the approach that they're considering and the conversation with stakeholders. So Emmanuel, would you like to begin?
Sure. Hi, everybody. Thank you very much for joining us for our second office hours. I'm very glad to see the turnout and that we're still seeing a lot of robust participation. So that is really great to see. I hope that this office hours today kind of helps to answer some of the questions that you all have. We did receive that slide deck that was sent by Cynthia this past weekend. So we're gonna try to address as much of that as we can. I don't really have a whole lot to say. I think one of the big takeaways that we should probably keep in mind is that this is EPE's first ISP or first attempt at an ISP. If you recall from our first workshop where we had that one slide, the crawl, walk, run. I think we were calling this IRP plus. So a lot of the requests that we're seeing and ideas on DERs are really great, but it's gonna be a process before we can actually get there to integrate all of these other planning environments that have, traditionally been in separate parts of the utility in the past. And as we're trying to bring all of that into one model, one shop, this is going to be a very long process. So again, we just want to make sure that we're meeting everyone's expectations. So Ben, you want to take it from here?
Okay, apologies. I was having some technical issues there. Let me just get back. Okay, just confirming you can hear me.
Sorry, Emmanuel, are you saying that this just doesn't magically happen? You actually have to do work?
Unfortunately, yeah, that is what I'm saying. So we've had a team of analysts and statisticians, an entire group devoted to this, plus all of the heavy lifting that E3 is doing, and we are barely scratching the surface of this. This is a multi-year process. Let's put it that way. It takes a while to build all of this into one model.
I think we all understand that. So thanks for taking the first steps.
Thank you.
Okay, can I just get some confirmation everyone can hear me and see my screen?
Yes.
Okay,
Yes,
thank you, Judy.
you're good.
Okay, so for today's agenda, starting from consolidating stakeholder requests here. So we'll just talk about, again, very briefly, the 11 different stakeholder request forms that we received a month or so ago. We'll then take a deeper dive into how we are going to model the C&I DR scenario within Plexos. And then we're going to talk in depth about how we are going to model the residential demand side solution scenario. Now, there's two components to the residential case. There's the DER, excuse me, enabled homes, and then also the time of use rates component for the residential scenario. Throughout this presentation, you will see these kind of blue boxes with some question marks. We do have some questions to discuss with stakeholders, but in the interest of time, what I am going to do is I'm going to walk through the 14 slides first. I will pose the question, and then when we've got through all of the slides, we'll circle back and just go through and have the discussions to try and get some answers to the questions, just to make sure we present all of the materials and don't get hung up on some of the finer points. On this slide, obviously, you see the safe harbor statement. This has been presented in each of EP's presentations to date, so I will not read this word for word, and we will skip on. And I'm just going to adjust my screen very quickly. Okay. So this was a slide that was presented in the fourth stakeholder meeting, so the last stakeholder meeting. And this was how we grouped the 11 different requests together. And we grouped them really based on kind of core objectives of the scenario or the core questions stakeholders were looking to answer. And we kind of broke them into the three categories, which was demand response. So if you were to expand demand response programs, could you offset the need for new peaking gas generation? The second question was, if you were to implement time of use rates and essentially offer incentives for customers to move generation from peak hours to off-peak hours, again, could you improve the load factor and avoid the need for peaking types of resources? And then finally, there was several requests to look at behind the meter type alternatives, so DERs such as residential solar and storage, and then also embedded within those scenarios, also additional demand response. So now we propose two different scenarios, if you recall from the fourth meeting, one C&I scenario and one residential scenario. And I've got just one slide for the C&I scenario that I'd like to quickly run by everyone on this call. The way we intend to model the C&I scenario is we will model 100 megawatts total DR on EP system. So this would be their existing demand response plus an expansion of that program to form a total of 100 megawatts. Now, I will say 100 megawatts in this case is kind of, I don't want to say it's irrelevant, but it's flexible. So if we were to have changed 100 megawatts to 200 megawatts as an example, we expect these results to be somewhat linear. So I think the number is kind of less important in this case. And then from a modeling perspective, we will model the maximum depth for the DR program is 100% of its nameplate. In other words, you could implement 100 megawatts at one time. And then based on some discussions with EPE, we will assume the maximum duration for the program would be 6 hours per call. So for 6 hours contiguously, you could interrupt load up to 100 megawatts. And then in terms of seasonal frequency, it would be 12 calls per season or 12 days per season. And then the maximum daily frequency would be 1 call per day. So essentially you're saying once a day for 12 days in a season, you could call upon 100 megawatts of demand response for up to 6 hours. And we would model the demand response as we call shed demand response. In other words, you're not shifting load from 1 hour to another hour like you would with time of use rates. We're simply assuming that load goes away. So I'm going to just pause there, Margie, and see if there's any kind of questions, clarifications from any of our stakeholders on the phone.
Yeah, thanks, Ben. And in particular, those of you who are here today that represent commercial, industrial, or military loads that this would apply to, we want to hear first from you and then take comments from others. So please speak up if you are part of the large commercial, industrial, and military customer set. And then if we have no questions from that group, we will take questions and comments from others. Hearing no questions or seeing hands from our commercial, industrial, military stakeholders, let's open it up to anybody. If you have a question, please raise your hand and we'll call on you to add your comment or question about this parameter set for the C&I demand response scenario.
Margie, I can't find my little hand on the computer, so I'm using my hand.
Go ahead, Cynthia.
Thank you. So Ben, as I understand this, then 100 hours is about 10% of, or 100 megawatts is about 10% of the first 100 hours of load. I think what we looked at a few weeks ago with Chris is that the first 100 hours of load included about 750 megawatts of EPEs, or almost a third, or approximately a third of their load. So this 100 megawatts for C&I at 6 hours and 12 calls seasonally is certainly more than what you have now. But it still fits within the using it as an emergency resource rather than something that's actually bringing down that first 100 hours that you have such low utilization. So that's your choice. And I guess I'm feeling like the results are going to be disappointing in terms of magnitude of effect. And I didn't quite understand how, well, you said 200 megawatts would be essentially linear. So I guess we could always extrapolate that 200 megawatts would give us a 2 times bigger result.
Yeah, so Cynthia, I maybe, excuse me, just want to push back a little bit on some of the load curves that we've been looking at to date. The load curves that we've been looking at to date are gross load curves, so system peak, right? And what
Right.
becomes more important as you start looking at critical periods is net load hours, right? So load hours less solar production at the time. So I think like the 100 megawatts we're looking at here would be 100 megawatts where you would be prefer to look at your net peak hours. So it'd be a little bit more impactful. And then to your point, I would say what we expect to see is 100 megawatts of demand response would offset in the least cost case 100 megawatts of gas generation. And then in the cases for New Mexico that do not allow new gas, you would expect it to offset 200-ish megawatts of battery energy storage, right? If you assume a 50% ELCC. So I think you could, to your point, just then extrapolate those numbers to a point, right? Where you could say, okay, 200 megawatts is going to do about the same. Now, I would say there's a curve there, right? It doesn't go on forever. But if you're looking at 100 to 200, I think that would be a fair approximation.
Okay, and then that's a good point on the gross versus the net. And EPE did give me a low duration curve of both gross and net. And what I recall from looking at that is that it has the same slope to it. It just, as you say, comes in maybe 100 megawatts lower on the net basis than the than the gross basis.
Yeah, and we should expect to see that to increase as EP work towards the renewable portfolio standards in New Mexico. Just because of their geographical location, you'd expect to see a continued additions of solar generation being added, and then further giving you that kind of that duck curve that you saw in California.
And then you said it would be about 200 megawatts of solar plus battery.
I would expect it to be approximation subject to the modeling being complete, somewhere in the region of 200 megawatts of batteries being offset, for the simple reason you expect them to have a 50%-ish ELCC.
Okay, and last question or point before Steve jumps in is that a group of us, a DER working group, and that's who sent you in we worked on that PowerPoint set of slides that we sent to you. We're interested in seeing additional value added model to this, and maybe you're getting to that in your slides, and we'll actually be able to include more value besides just the generation.
Yeah, I'm going to come to that when we start talking about the DER solution.
Okay, thank you.
Thanks, Cynthia. I see Glenn, you have your hand up. Go ahead, please, Glenn.
Yeah, now that I see this laid out on one slide, I'm thinking it might be useful to just turn this around, and in any scenario that determines a new peaking plant should be built and is cost effective, you could look at, and I don't know if you'll be reporting how often it is called, how long it's called, because that would tell you what sort of demand response program would eliminate that plant, right?
Yep, that's exactly the point here, Glenn. We would look at this scenario and say, okay, this demand response program under these set of parameters avoids, storage or a CT as an example. And then you could look at how often it was called upon, the frequency, the duration, and that could potentially help EP determine whether expansion of a DR program would be cost effective, and also whether there'd be customer participation, of course.
Okay, yeah, and another factor in this is how much import you're going to accept, how much imported capacity you're going to accept for the peak hours, right?
Yeah, so Glenn, just to clarify, and I'm learning to be very tight with my words here, so apologies if this comes across as a little bit pedantic or picky. When you say imported capacity, are you talking about just imported energy during those hours?
Yeah, I'm at energy,
Okay.
yes.
Yeah.
So I guess the question is, do you have a limit on imported energy that you're working with?
Yeah, we have an import based on current transmission import capabilities. And then we have one additional scenario where we assume increased imports from the Southwest Power Pool. So it would be subject to whatever those constraints.
And I think, Glenn, the parameters of that, Ben, you described that in the last workshop, right? So Glenn, you can go review the materials from the last workshop and see the parameters of that import scenario.
Yeah, good catch, Margie. There's a map, there's a topology map in the 4th stakeholder meeting materials.
Yep. Great, thanks, Glenn. Steve, I think your hand's up next. Please go ahead, and then we'll move to the residential conversation after this comment or question.
So Ben, does this, when we're looking at this demand response scenario, does this preclude any other measures such as a revision of TOU rates for C&I customers or other similar steps?
In this one particular scenario, we would isolate just demand response as being the only change, just so you've got a control measure, because if you start implementing multiple different changes, it's hard to see what the driver is, right? Did demand response drive the avoidance of a CT, or was it the time of use rates? So in this one particular scenario, it's a controlled change of just this one input. When we go into the next residential scenario, that does have a combination of DER, DR, and TOU all rolled into one.
So is that something that could be addressed going forward? Could we also take a look at the general rates? I'm kind of responding to, well, definitely responding to the issue that Cynthia raised, is that this is kind of standard demand response with industrial customers. But Cynthia was pointing out that this is not something that's kind of automatically built into the system to increase efficiency of power utilization by the C&I segment of the business. So I, for one, and I don't know how anyone else feels, would like to have the ability to model additional load management efforts. It could be TOU rates, it could be use your imagination. But I personally would like to have the ability to model those multiple things going on to help reduce that load.
So Steve, maybe just to push back a little bit there, the main purpose of this scenario was to look at new, and it wasn't initially designed for just data center load. I want to make that clear. It was a C&I kind of scenario.
Yeah.
But a large portion of this driver was to look at extremely high load factor potential data centers coming onto the system. So that's where I get a little bit tricky with load management and time of use rates, just because they have minimal intra-hour flexibility between their load.
No, I understand what you're saying there, but I don't think. I guess my question is purely, can we layer on multiple programs to help flatten that load, multiple steps, in addition to this particular scenario, which to me looks fine. But again, it's very hard in the real world to learn if we're doing everything one at a time, waiting for 3 years to see if it works. And a lot of times you can find synergies between programs that frankly supercharge them if we're doing, if we design them correctly and we put them together. And so what I'm looking for is, can we imagine some other things we do with these C&I customers and model those in combination with this?
Steve, sorry to interrupt, but let me show you the next scenario, because the next scenario, even though it's called a residential scenario, quite frankly, from our modeling perspective, it doesn't matter if it's residential or commercial, right? We don't model it in rate class. And I think this next scenario, even though it's called residential, addresses your concerns.
Okay, thank you.
So let's go straight into it. So again, this one is called residential, but I just want to be very clear, as I was just saying to Steve, the components could be applied to C&I customers is just as easily. It may be just a little bit of a clarification here. This is a generic scenario for a DER-enabled home. We have obviously relied heavily on stakeholders to help influence these inputs and provide some expertise here, but we are not modeling a specific company's product here. This is a kind of a generic DER-enabled home. And then we also, in addition to this, we'll talk about time of use rates at the end of this presentation. So just to talk really quickly here, again, what we're looking at doing, Steve, to your point, is assessing a combination of time of use rates, DR, and then DERs to try and help solve the issue here, which is flattening the load curve and then also exploring alternatives to peaking generation. So as we look at this model here, we would model each individual home with a 13 kW solar system, rooftop solar system, a 12 kW behind the meter battery energy storage system, a 14 kW demand response program, a 15 kW inverter, which we'll talk about in a moment. And then the demand response, once again, for modeling purposes, would be shed demand response. So we're just assuming when you implement the demand response programs, the load goes away. And then in addition, there'll be some energy efficiency embedded within these homes. So let's talk with the number of homes that we're going to be looking at. So for the purposes of modeling, we would be looking at 2,500 homes on an annual basis for 10 years. So hopefully everyone can do the math there. That calculates to 25,000 homes over a 10-year period. And we would assume that all of the components embedded within this scenario would be incremental to what is currently in EPE's forecast. So when we talk about behind the meter solar here, storage, demand response, we are not simply replacing what's in their forecast with these products, we're adding them on top. So this is incremental. And then the energy efficiency component that I'm not really going to talk about in detail today is just going to offset the load forecast. Some of the questions that I would like to circle back to, as I mentioned earlier, towards the end of this presentation, are just how we kind of talk about the load of these additional homes. Do we assume the 25,000 homes are incremental homes to EPE system, which I probably wouldn't recommend? And then also I want to talk briefly about if a DER-enabled home has more consumption than a kind of a traditional home. So we'll circle back to these more detailed questions in a moment. But let's talk first about the behind-the-meter solar. So every 2,500 homes provides 32.5 megawatts alternating current of solar generation. So over the 10-year period, you're getting up to 325 megawatts of residential solar on top of what is on EPE's current forecast. Based on feedback from stakeholders, we would be modeling this fixed residential solar at a 21% capacity factor. And very importantly, I want to just kind of call out this bolded section. I saw this in Cynthia's presentation. We will gross up the generation by about 6.5%, which is EPE's transmission and distribution losses. So what this is saying is it's giving it that advantage over remote or centrally sited supply side resources. So you will be capturing the benefit of customer sited resources in this product. And then prior to grossing up for T&D losses, every home generates about 60,000 megawatt hours per year. Excuse me, every 2,500 homes generate 60,000 megawatt hours, give or take a year. We would be modeling this behind the meter solar generation at zero marginal cost as a must-run resource. So essentially the solar is going to be earliest in the dispatch stack, so the solar will be generated first. Now, that's really important because I sent out some clarifying emails over the last couple of days in what is a load modifier versus what is a resource. And from an energy perspective, it doesn't matter. You have a load curve or a load profile. You could either subtract the solar generation from the load profile, or you could enter in the gross load profile into Plexos and then just have the solar resource as a must-run resource, and it takes you to exactly the same place. So that is how we will model the solar generation. Now, I mentioned earlier the 15 kW inverter limit. That's essentially saying the solar generation plus the discharge of the battery at any one point in time cannot exceed 15 kW. Now, as we look at modeling the behind the meter storage solution, so every 2,500 homes provides approximately 30 megawatts of battery energy storage capacity. So 25,000 homes provides 300 megawatts of additional storage. And the assumption going into this model is the batteries will be fully dispatchable by EPE and they can be grid charged. They will also be operated for energy arbitrage, which we expect to provide the most value. So what that means is we will charge the batteries when prices are low, the marginal cost of energy is low, and we will discharge the batteries when prices are high. And for simplicity here, we are going to assume it is 100%, as I mentioned earlier, dispatchable by EPE. So the residential customer cannot hold back, 10% of their battery capacity for emergency use. This would be the most aggressive assumptions for arbitrage. And then for round trip efficiency, again, provided by stakeholders in this process, we will assume a 91% round trip efficiency. So what that means is for every 100 megawatts of energy you charge the battery with, you get out 91% of megawatt hours coming out the discharge end. And we will limit the battery to the maximum annual throughput equivalent to 365 cycles per year. So we would assume to avoid degradation on the battery, you could essentially fully charge it and fully discharge it once per day over the course of a year. That typically isn't a technology restriction, it's a commercial restriction. You just don't want to just go through the batteries too quickly. And then again, just kind of looking at the questions here, we'll circle back in a moment and talk about whether we do 4, 6, or 8 hour battery energy storage on these homes. And then demand response, every 2,500 homes provides 30 megawatts of demand response. So 25,000 homes provides 350 megawatts of additional demand response on the EP system. So again, keep in mind when we look at the CNI scenario, we've got 100 megawatts. In this scenario, we've got 350 megawatts, albeit with some other solar storage and some energy efficiency. But it's going to start to give you those range. You're going to be able to start to assess the impact. And then we'll be making similar assumptions in terms of maximum depth. You could use the demand response to 100% of its nameplate. As I mentioned earlier, we'll be assuming it's shed DR, not shift DR. And we need to talk about duration of course, frequencies, both seasonal and daily in a moment. So up to this point, just going back, we've really talked about from the solar and the storage perspective, its energy contribution. So how does it, one, offset load, and two, charge a battery when prices are low and discharge a battery when prices are high. Now we're going to talk about its capacity contribution. So we will model the storage, DR, and solar using the same effective load carrying capability that we would model supply side resources on. So each of these resources will be given accredited capacity that will offset EPE's plan and reserve margin requirements. So you will see a capacity benefit of providing these resources. What does that mean? It means as you add demand response or storage to these DR-enabled homes, you're going to reduce your capacity need for gas peaking units, battery energy storage, and other capacity resources. And now on to the fun part. How do we model the cost effectiveness of DR programs? So there's two alternative approaches to doing this. One is you assign a cost to the DR enabled homes. So you say, hey, we expect these homes to cost X amount of dollars per year. And then you plug that cost into your capacity expansion model and you see if the model selects it. And if the model selects it, it's determined to be more cost effective than supply side resources. If you recall, in the fourth meeting, Mr. Simpson asked, well, hey, I don't really want to see it done that way because of scales and efficiency, typically you're usually going to see utility scale resources win over DERs. So the way we're actually proposing to model this scenario is to model the DERs at zero cost. So there will be no cost assigned to any of these homes. That means the model will 100% select these resources. They're going to be zero cost. So let's just ignore this red box for just 1 second. And let's talk about this orange box here. Excuse me, I'm going to just shut off my Teams just so we don't get pinged. Okay, apologies. So we have this orange box that will show the system cost without the DER enabled homes. And then we see this blue box here on the right, which would be the system cost with the DER enabled homes. Now, as I mentioned, because you're modeling at zero cost, you know it's going to be cheaper. The system cost has to be cheaper. So the difference between the two will be the avoided cost of energy. So how much benefit do these DERs provide? Now, the way we can look at the avoided cost of energy is also the economic break-even point. So if these homes provide $100 million of savings, if they're modeled at zero cost, then anything above 100 million would represent additional cost to customers. Anything below 100 million would represent customer savings. And then the more tricky part is these additional value streams. So what can we capture in Plexos in the capacity expansion and production cost modeling today? Well, we can capture avoided energy. So as you add solar resources, they're going to be modeled at zero cost. You're going to avoid energy being produced from other thermal units, for example. Each of these resources is going to be assigned an effective load carrying capability. So you're going to avoid capacity being built to meet the plan and reserve margin requirement. You will see a reduction in transmission and distribution losses because you're going to gross up the energy production to account for T&D losses. One thing we've talked about several times in this meeting is load factor improvement, or in prior meetings, excuse me. The models on an 8760 basis. So you are going to see load factor improvement as you flatten the load curve by adding solar resources, or flatten the net load curve through adding solar resources, and you add storage, you will see improvements to load factor. And then we can assign a value to avoided greenhouse gas emissions, social cost of carbon, for example. Also within Plexos, you will see thermal resources operate less. So you're going to see less fuel costs, you're going to see less variable O&M, and potentially you can also see less maintenance costs. So if you assign a start cost, for example, to a simple cycle CT, and that CT starts less frequently, then you're going to see avoided start cost, avoided capital expenditure. Sitting in the middle of what we can capture and what we can't capture in Plexos is ancillary services, which is a tricky one. So ancillary services, we can capture, for example, reduced spinning reserve requirements. So within EPE's model, we have, I think it's a 3.5% reserve requirement for spinning reserves, resources that can ramp up quickly in order to meet fluctuations in load. What we cannot capture in Plexos is things like frequency support. So there's kind of this blurry line with ancillary services where we can capture some and we can't capture all of them. And then what we cannot capture in Plexos is avoided transmission and avoided distribution. The first one, there's a little bit of caveat to that. If it was a very large amount of avoided transmission, we potentially could capture it because we are doing a zonal model. But what we expect to see in terms of these homes is kind of below that threshold. So we will not see avoided T, and we will not see avoided distribution because, as I mentioned in the last meeting, we will not be modeling the distribution system. And then there's other qualitative benefits, for example, risk reduction. Same with resiliency. If you site generation at the customer meter or behind the customer meter, does that provide a resiliency benefit to the system that is more subjective and more qualitative than it is from a pure modeling input-output perspective? And then there's various other benefits we could discuss today that probably are not captured in Plexos for DERs. And then just to round off the last component, which is still very much a work in progress right now, is the time of use rate. So what we have asked EP to do, well, what E3 have asked EP to do, so we can look at modeling this, is to create an alternative load forecast. So the alternative load forecast will assume increased participation in TOU rates. And what that would do is it will move, at the moment, residential load from peak hours to non-peak hours. And then the expectation again there is you would build less peaking resources, gas generation, battery energy storage to meet peak conditions. As I mentioned, that's kind of a work in progress. That's taking, that's quite a bit of work to do a whole new load forecast. So we're probably going to be presenting that in the meeting prior to kind of really kicking off this demand side solution scenario. So I do want to maybe, just before we go off subject too much, I just want to circle back to the questions that we had and maybe just spend literally, a couple of minutes on each of these questions. And if we need to, we can obviously send these questions away with you guys and then get email or chat feedback. So Margie, did you want to handle these questions, or would you like me to?
Yeah, why don't you handle them, Ben? I know we did have a question from Jim Desjardins on slide number 8 when you get there. So Jim, stand by, but go ahead. I think, Ben, go ahead and ask your questions as you know exactly what you need from the stakeholders.
Okay, perfect. So let me start with what I hope is a nice, easy, soft question to get everyone into the mood here. So as we talk about adding 25,000 homes to EPE's territory, DR-enabled homes, my assumption is these homes will not be incremental to the additional houses that are being constructed in El Paso service territory, but just wanted to confirm that assumption and see if there was any objection. My expectation is DR homes are not going to make people move to the area, but wanting to hear other thoughts.
Go ahead,
Ben,
Chris.
this is Cynthia.
Sorry, Cynthia. Chris has his hand up. I'm going to have him go first, please.
Okay.
Sorry, can you ask that question again, Ben? I wasn't 100% sure I followed it.
So Chris, at the moment we have a load forecast from El Paso Electric that assumes some level of residential growth over the planning period. As we add 25,000 homes to the model, my assumption is those homes just replace existing plans for new construction in the area, and these homes are not incremental to whatever is currently in the load forecast.
Oh, yes. Okay, sorry. Fully understand. Agree.
I told you I'd start you with a nice, easy one, Chris, just to get the juices
Well, if
flowing.
that was the easy one and I didn't understand it, I'm scared of the next ones.
All right.
This is Cynthia. I wanted to say that I agree with that. I had misunderstood earlier and thought that this was actually a new load coming on the system. So just replacing existing housing or improving existing housing makes sense. Thank you.
Perfect. Okay, so that was the nice soft question. Let's ask the slightly more difficult question. So related, do we just assume the DR-enabled homes consume the same amount of power on a monthly basis? Or do we assume they have, heat pumps, etc., and we should increase the load forecast to account for these DR-enabled homes?
You mean increase the load forecast in the winter and summer to account for all electric HVAC?
Yes. So if we say, Cynthia, a standard home is 1,000 kilowatt hours per month, should we make the assumption in this case that these homes are 1,000 kilowatt hours a month, or should we say they are 1,100 kilowatt hours per month as an example?
Well, if it's only that much of a differential, I say go with the heat pumps.
Well, and I don't know. So Chris, I maybe going to defer this one to you. Do you have any gut feeling here?
I think that, again, I'm not 100% sure, and apologize. I think I actually did this stuff once before with EP, but within their 10-year load projection and all of the new home construction they have and everything else, I don't believe that they assumed all electric homes for any percent of that. So I would take at least a swag to say that I think 50%, you'd lean toward 50% being all electric, which obviously changes the load shape heavily because the heat pumps will use a lot more energy in the winter and less in the summer, right? So, and I'm sure that EP has some good data for any subdivisions that have been all electric versus combined gas and electric. So this is just a brainstorm. I'm thinking that probably at least 50% of them, we ought to assume that we're moving towards an all electric subdivision. What do others?
Remind me, Ben, what you said about cost. This was all going to be at a no cost or some cost?
we would model the components of this system at zero cost. So the residential solar storage, for example, but the increased load. So if you said a all electric home did have additional consumption over a traditional home, then that cost would need to be reflected within the model. That load would have to be served.
So
Randy,
I
go
have
ahead.
this is
So
this is
Ran-
Randy.
Go ahead, Randy.
So we have another model about fuel switching, which is really adding heat pumps. And in that one, we asked for a linear, 6% by 2030 and going up to 75% by 2050. I know that's kind of beyond the time scale here, but you could almost kill two birds by combining those two together.
Okay, so what I'm hearing, and again, sorry, to Chris's point, we don't need all of the answers today. It is a brainstorming session. So Randy, I like that idea, and I know the scenario you're talking about. Why don't we and the EP team go away, have some discussions internally, and see if that Los Cruces electrification scenario input would align with this assumption.
Randy's got a thumbs up on that.
Okay. They get easier. I went from extremely easy to hard, and now they get kind of middle of the ground. So I'll move on. But before I do, Margie, did you say there was a question on
Yeah,
slide 8 here?
Jim, are you still online? Would you like to ask your question? It was a clarification about the capacity factor. Jim, are you there?
Yes, I am. Yeah, I just quite honestly just didn't understand what you meant by 21% capacity factor.
So 21% capacity factor. If a generator was able to generate its maximum output for all 8,760 hours of the year, it would have a 100% capacity factor.
Okay.
And if it has a 100 megawatt generator, 8,760 hours a year would have 876,000 megawatt hours of energy per year. If you have, for example, a wind farm, and I'm going to pick that just because the math's easy, well, it had a 50% capacity factor, a 100 megawatt wind farm would be able to generate somewhere in the region of 430,000 megawatt hours a year. So 50% of the maximum capability.
Okay. All right.
So
Yeah,
a solar resource can basically 21% of its maximum output over the course of a year.
got it. Okay, that's helpful. Yeah, that makes sense.
And Jim, just to confirm, that's 21% prior
Yep.
to grossing up for T&D losses.
Mm-hmm. Yep. Thank you.
All right, let me give you guys a nice softball one here. Any thoughts on the duration of the energy storage on the homes? We were thinking 8 hours initially, just for the simple reason EP have added a lot of storage to the system, or will be adding a lot of storage to the system. It's going to have to start getting longer duration to continue to provide value, but happy to hear stakeholders' thoughts here.
I see, Steve, you've got your hand up. Go ahead.
Actually, forget it. My question was not a good one.
Okay, all right. Well, Kara, please go ahead.
Thank you. I was wondering from EPE's perspective if there would be incentives offered to customers for the battery storage devices, and would that be proposed under the energy efficiency plan, or what are you thinking will encourage customers to install battery storage?
Cora, just before I hand that over to the EP team to provide their thoughts, just want to be really clear on the outcome of this model. So this outcome of this model is going to essentially give you the avoided cost, right? So by adding this storage at zero cost, how much does it avoid in terms of alternative approaches, alternative system costs? So that would tell you, adding this customer solution is going to save customers $10 million a year. And only after you've done that analysis can EP then go away and determine how they then allocate those cost savings to customers and how they get cost recovery from those savings. So from my perspective, the modeling that we're conducting today will not answer that question. But obviously I do want to speak on EP's behalf, so I'll hand it over to Emmanuel and team.
Also, that may be a premature question, so I'm totally fine with your answer.
Okay, perfect.
Ben, you hit the nail right on the head.
Okay, thank you, Emmanuel. So any strong feelings against modeling the storage as 8-hour storage?
Go ahead, Phil. Phil, I think you're on mute. Go ahead and you have your hand up.
Sorry. Yes, you're right. I was on mute. I was trying to turn my video on. But anyway, I agree with the 8-hour approach. I agree with that 4 hours is getting a little bit common, and we're going to have to make it longer to have more of an impact.
Okay, great. Thank you very much.
Go ahead, Jim. Jim Desjardins, would you like to ask a question or a comment on this?
Sorry, I have my video on, but not my sound. Okay, so kind of going back to what Kara was mentioning, right now, the attachment rate of energy storage with a behind-the-meter solar system in New Mexico is about 1%. And this makes an assumption of a much, much greater amount. Any thoughts on how do we get there?
So again, Jim, like to give you kind of a non-answer there, like my thought is this is just the first test, right? Is this economically feasible first? And then once you kind of answer the question, what are the economics of this project? Then you've got to go into how do you implement that strategy? So Jim, I don't think like just producing this modeling, does this answer the question, is it feasible to build 25,000 homes in 10 years? No, that is not what we're going to answer in this modeling. What we're going to answer is what do the economics look like? And then if this passes an economic cost benefit test, then the action plan, in my opinion, again, not speaking for EPE here, should be how do you then implement that plan? How do you implement that strategy?
Thank you.
Great. And I see, Steve, your hand is up. The question on the table is, do people agree with an 8-hour duration of energy storage?
Yes, I agree with 8-hour energy storage. But I had a further question regarding the modeling, and it's a little bit tricky. So, Ben, it seems to me that the economic savings from implementing this package of steps changes depending on whether you put it on a congested line or a not congested line. And how do you propose handling that in the modeling to come up with something that's meaningful for us to evaluate?
Yeah, so looking at EP service territory, and I'll let EP jump in and give me some more information here. I'm looking at this as being two load pockets, so the city of El Paso and the city of Las Cruces. So we have a zonal representation of those zones within the model. So we will capture intra-regional transmission constraints, but we will not go down into the distribution level. So that goes back to my point here, Steve, is we can capture avoided transmission at a high level, but probably not necessarily for this level of additions. And we will not be capturing avoided T and avoided D here.
Okay, so that would be something we'd have to do in a kind of a clap-on analysis to add to the model.
Yeah, so this comes down into these like additional value streams when you start looking at them. And in order to really fully appreciate how much you could attribute to not just congestion, but avoided distribution in terms of feeder build and stuff, you would have to do like a very detailed study, point to point, knowing exactly where these additional loads are being added to the system.
Okay, thanks.
Randy, I see your hands up. Is it on the issue of the duration of storage, or should we
Yes,
go to go ahead.
duration. No,
Yep.
just a question, if we go to 8-hour duration, do we reduce our ability to minimize our ability or cut it in half to reduce peak load?
Say that one more time for me, Randy. Sorry.
So peak load typically occurs in A4, but now maybe getting to be a longer period. If we're stretching our storage duration, does that reduce our ability to bring down the peak load?
I would say, on the contrary, it increases your capability of fulfilling, and I want to point out distinction here, net peak load. So at the moment, the EP system is an extremely peak system on a gross basis. But as you continue to add solar to the system, you depress the gross peak. And what you do is you move that load into the later hours. And during those later hours, because you don't have, obviously the sun's not up, you increasingly need longer duration to have further impact to your net peak load. So I'd say 8 hours actually provides more of a benefit than 4 hours would.
Okay, that's what I would be shooting for as well. So sounds good.
So Ben, let's continue with your questions then, because I know I see there's also, let's go through this, the demand response parameters, and then Orland Whitney has a comment that I'll ask him to come off mute if he's able and to share his thoughts about the context of this modeling. So let's focus on this one for now.
Okay, I think this is my last question. Let me just double check. Yes, it is.
Okay.
So as we look at the same modeling parameters for demand response on the residential side, one way to do this would just be to mimic the C&I side. So again, do 4-hour call duration, 12 calls per season, and then 1 call per day. But just wanted to, maybe pose this question to stakeholders and just see if anyone had a strong opinion against just mimicking the C&I program.
Could you restate that, or Ben? I
Yeah.
lost the gist there somehow.
Yep, absolutely. So the C&I program assumes 4 hours per call is the maximum duration. It assumes 12 calls per season with a maximum daily frequency of 1 call. So as I mentioned earlier, once a day, 12 days in a season, you could call upon, and excuse me, I'm going to correct myself. The duration is 6 hours. Apologies. So just wondering if we just want to mimic those assumptions, or if anyone has a strong feeling why it should be a different assumption here.
Wouldn't somebody who has,
Chris.
I'm sorry, I'm jumping.
Sorry,
Go ahead.
Chris. Go ahead, Chris. You've got your hand up. Chris, can you come off mute?
Sorry. Yes, just quickly, is the assumption for demand response that it can be used in reserve margins on a day in, day out basis, but only, executed or counted against that period of time for these call durations? Is that correct or incorrect?
Chris, can you say that one more time?
Sorry, I'm trying to get to the point of making demand response more used and useful. And as a resource that can be called and dispatched, it could be utilized in the utility ancillary services pool as spinning or non-spinning reserves based on its response capability, right? So if it could be scheduled literally daily, as long as it was available above some temperature or different things, EPE could gain value from that scheduling capability, but only has the quote call ability for so many times. Just trying to find ways to make demand response more valuable for the utility and their customers.
Yeah, so in both cases, Chris, in both the CNI case and this case, the residential case, the demand response could be called upon for economic reasons as opposed to just emergency situations. So we would assume, to your point, that demand response is essentially dispatchable. So you could call upon demand response for economic purposes under the limitations shown on the screen here. So if you assumed demand response, for example, was called upon 30 times, 40 times a season, then EP could call it 30 or 40 times a season for economic purposes.
Cool. And so, but on the days that they don't actually call it, they could still use it in their reserves, saying it's there, it's available to be scheduled, but if we don't need to call it today, it helps us, correct?
From an operating reserves perspective, yes, but we in the model were only talking planning reserves.
Okay.
I also saw hands from Glenn and Randy. Are you still, Glenn? Would you go ahead, Glenn?
Yeah, I'm still trying to wrap my head around the residential demand response. So it's made up of solar and batteries. Is that correct?
The DER pieces, so you have solar and batteries, and then there's also an assumption that there's additional equipment in place, such as heat pumps, which you could essentially interrupt service to in order to cut the demand of these homes.
Okay, yeah, now it's looking a little more like a virtual power plant. Okay.
Yep. So Glenn, just be very clear. This could actually be called a virtual power plant. There's just lots of people who call this same configuration different names.
Gotcha. Okay. So let's talk about solar first. So if we need extra capacity, you're not going to get it from residential. That's just all.
Glenn, you're breaking up for me. I'm not sure if that's the same for you, Margie.
Yes, you're breaking up, Glenn. Could you repeat that? Appears we may have lost Glenn. So let's go to Randy. We can come back to Glenn if he comes back on. Go ahead, Randy.
Yeah, I think my question was very similar to Chris. I just want to make sure that we're going to be taking advantage of energy arbitrage every day of the year, or at least until we need it for peak, net peak reduction.
Yeah, so if you add behind the meter storage to these homes, every day of the year, you're going to be operating the storage for energy arbitrage purposes. And then if you assume that you have a pretty substantial battery on these homes, then the demand response will be used to shave peak or used to shave resources being provided for the critical period. So I would not expect you to call upon residential demand response every single day just because you have this large well of batteries you can also call upon.
Thank you.
Glenn, are you still there?
Yeah, I could try again, and you partially answered the question. Can you hear me now?
Yes.
Yeah, sorry, I'm in motion, so I was in a bad spot. So you said that you would be operating those residential batteries 24/7. So the idea is that they're under the control of EPE all the time. Is that correct?
For the purposes of the modeling, that's correct, Glenn.
Okay, yeah, that largely answers my question. And then with the solar, it just produces when the sun is shining. There's no real control unless you need to curtail it, right?
Correct. Yeah. So for the solar, what we would do with the solar is we would model it as a must-run resource. So essentially, the solar would only produce energy, obviously when the sun is shining. Now, you probably wouldn't curtail for the simple reason you have a very large battery storage facility there. So for the most part, anytime you would potentially curtail the solar, you would probably be charging the storage with it.
Yes, okay, that makes sense. So I still have to think a lot about this 24/7 operation of the batteries. Um, so there's almost another program that's not demand response, or you said arbitrage. So potentially the customer is being paid for arbitrage.
Correct. Now, I do want to just go back then, just to clarify 24/7 operation. It is limited to the number of cycles per year. So essentially, you could charge the battery once per day and discharge it once per day. Now, that's a little bit of a simplification because we average that over the course of a year, but you couldn't continuously charge and discharge it constantly. You would need to have some break within just to maintain the commercial terms of lithium ion.
Yeah, that totally makes sense. So maybe one other point here is that there's no voluntary demand response at the residential level. It's entirely under the control of EPE in the way you're modeling it, right?
In the way we're modeling it, Glenn, yeah. And I just can't stress that enough because we're going to model it in a certain way and then show what the economics look like. And then, of course, it's up to EPE to design the program, how it operates, what the cost structures are, what the credits are, etc.
Great, thanks.
Great, thank you. And so, Ben, before I ask you and Emmanuel to talk about your next steps, we had one other comment question from Orland Whitney. Orland, I don't know if you're still online.
Yeah, of course.
Are you? Yeah, would you like to state your comment and
Yeah,
give a response?
so I just kind of like, I'm a big picture guy, so I want to make sure that, are we talking about minor adjustments here on your inverter functions, or in the grand scheme of like I say, my training is electrical, not economics, but I'll say, are we looking at fine tuning the end of EPE's IRP, or are we I just don't know if we're nitpicking the curve as we're discussing about overall costs borne by ratepayers. I'd like to understand how that is weighed in your IRP. How what costs are we attacking from a volumetric basis? That's kind of what I'm trying to understand.
Yeah, so Orland's big picture here, and kind of coming out of the weeds, is once we get done with this modeling, we will be able to quantify the cost savings of implementing this type of program, assuming zero costs of its implementation. So we'll be able to turn around and say, hey, you saved building 2 CTs, you saved $100 million in fuel, you saved $50 million in capital expenditure, and overall you saved $100 million, just throwing a number out there, over a period of time. And then hopefully in the action plan, EPE then will be able to talk about next steps in terms of how they determined whether the cost of implementing such a program would be lower or greater than the avoided costs we're looking at here.
I think that was perfectly explained.
Great, thank you, Orland.
Good. Ben, is there anything else you needed to ask of the stakeholders before we ask you and Emmanuel to talk about next steps, and then we can talk about just reminding people about the next workshop on the 21st of May. But anything else you need at this point, or do you want to summarize where you are and where you're going to go from here?
Yeah, I think for the most part we got the directions. I thought it'd be good just to have some questions just to get everyone talking about this. So I think we have all of the inputs and assumptions that we need to start the modeling process within Plexos. So at this point, I think we are good on the E3 side, but obviously throw it over to EP just to see if there's anything those guys are looking for.
Hey, this is Judy. I'll take a first step in some of the next steps, and Emmanuel, feel free to step in. But yeah, just first of all, we just wanted to thank everyone again for participating in this. You know, we said that we would host an additional office hours to answer some of your questions, and our hopes is that the presentation that Ben gave today and some of the information, given the comments that you all had, would provide some additional context and help to do that. As Ben mentioned, you know, again, next steps, we're going to start on the modeling process. All of your input is extremely valuable. But in addition to that, you know, we'll have the May 21st meeting, which will be our next meeting where we'll get into more details. And again, I just really want to reiterate, you know, Emmanuel's comments at the very beginning. It's a process. So, I mean, we're transitioning to an ISP. You know, we're one of the few utilities in the country that are doing that. The first one in New Mexico. We're super excited about that. But with that, again, it's a process. So we're taking more than baby steps, but there are a lot of different components that go into it, and we're really excited how this is transitioning to a full-blown ISP in the coming years.
Great, thanks, Judy. And just to bring closure to this, as Ben started out, there were 11 stakeholder model requests that dealt with the topics we've covered today. And I appreciate EPE and E3 considering those and trying to create some scenarios that would give some insight into the cost and potential cost and benefits of these resources. So at this point, Steve, I see you have one more question. Let me just thank EPE and E3 for having done this analysis and combining those 11, taking the 11 very thoughtful requests, trying to integrate them in a way that gave insight to all the stakeholders and to EPE as they pursue their IRP analysis. So Steve, do you have one more comment or question, and then we will close the meeting?
Yeah. So for my questions, probably folks have figured out that from the CNI standpoint, I'd like to see personally a more robust addressing of steps that could be taken on the demand side. And so right now I don't see that in the modeling, and we can take this offline, but I would like to explore that a little further. And, you know, Ben, maybe you can help me out with that.
Yep, happy to.
Great. And likewise, obviously hearing from our stakeholders who are representing those large CNI customers is a really important part of that. So thank you all. And if Matt, would you please show our last slide from the GridWorks deck? Again, thank you everyone for attending and participating in this process. We will be posting the recording of this meeting on the GridWorks website, along with the slide deck that Ben presented. And we look forward to seeing you all on May 21st, 1 p.m. on Zoom for workshop number 5, where we will begin to get insight from the base case analysis and perhaps other modeling subjects. So with that, thank you again for attending, and we will see you all on May 21st. Bye-bye.
Thank you all. Bye-bye.
Thank you, everybody.
Yeah.
Thanks.